All right. So good morning, everybody. In the next 2 hours thereabouts, we'll see what we can do on our lesson 2, which is on advanced teaching methodologies for computer science concepts. To give you a brief or an overview of what we are going to do this morning, we shall talk about 3 main methodologies for teaching. So these are the inquiry-based learning, the project-based learning, and the problem-based learning. What are these things? And how can we harness the power of these methodologies in our classroom? All right. So we start with the first one, which is the inquiry-based learning. So let us have this nice story to start with. Just imagine you are on a treasure hunt. So instead of someone handing you a map, which will be the easiest way, with a marked path, you are given clues and puzzles to solve. So instead of being given a map, you are just given clues and puzzles in such a way that your solution to these clues and puzzle will lead you closer to the place you are going. So along the way, you will make discoveries, and sometimes you can get missing. You may have to ask questions, or you work with others to find your way. So this process of exploring and discovering is at the heart of inquiry-based learning, especially in computer science. Okay. All right. So what is now inquiry-based learning? What is this? And what do we actually mean by inquiry-based learning? So inquiry-based learning, it has to do with active participation of the student in class, where students have the opportunity to pose questions, investigate problems, and explore solutions. In the heart of inquiry-based learning, we have collaborative effort, where students work together to construct knowledge through discussion and debate. And at the same time, the teacher's role in this methodology is now reduced to facilitating learning by responding to student thinking and their misconceptions in the classroom. All right? So this is, when we say inquiry-based learning, what should come to your mind are 3 basic things: active participation, collaborative effort, and then guided discovery. All right. Thereafter, we talk more about the foundations of inquiry-based learning. Inquiry-based learning actually has 4 foundations. I repeat, there are 4 foundations of inquiry-based learning. Number 1 is peer-to-peer interaction. For every inquiry-based classroom, there must be interaction between students. Students must come together, discuss solutions to a problem, or understand something together, or read something together, or explain something to each other in an inquiry-based classroom. Number 2 foundation is a deep engagement with the learning content. Deep engagement with the learning content. So for every inquiry-based learning activity, students should have the opportunity to engage with the content, to look into the content, criticize the content, pose problem on the content, and actively engage with the learning content. Number 3 foundation, 1 and 2, I must comment, 1 and 2 have to do with the student part or the student contribution in an inquiry-based learning classroom. So while the 3 and 4, they are basically on the teacher's role, what the teacher should do. So peer-to-peer interaction and deep engagement, they are activities that the student will perform in the classroom. While for the 3rd one, which has to do with teacher-responsive teaching, what does that mean? Teacher use of student thinking to foster learning. The teacher capitalizes on what the students know and use that to shape his teaching in order to facilitate the construction of knowledge. This is the 3rd foundation. The 4th foundation is equity in design. For every inquiry-based classroom, learning activities must be inclusive, must be accessible, and it must carry everybody along. This is very important. You have to design your study in such a way that everybody will be given the opportunity to contribute. Everybody will be given the opportunity to participate. Everybody will be given the opportunity to explore their potential. You don't just design your study, your class in such a way that only the brilliant students in the class will gain. You don't just design your lesson in such a way that only those that are coming to class will benefit. So you design your study, your lesson in a way that you carry everybody along. And this has to do with the assessment as well. You don't give assessment that we only involve people that are very good in writing, we pass. Or people that are very good in memorization, we pass. Or people that are very good in repeating what the teacher has said, we pass. You try to cut across, carry everybody along. You can give the reading part, you can give the practical part, you can give the presentation part as part of your assessment in such a way that if you don't get marks here, you get from there or you get from the other place. So this is when we talk about equity in design, this is what we mean. So I repeat, inquiry-based learning, it has 4 foundations. All right. The first one being peer-to-peer interaction. The second one being deep engagement with the learning content. The third one being teacher use of student thinking to foster learning, while the fourth one being equity in design. This is another role of the teacher. All right. Having said that, let us now explore some examples in which you can foster peer-to-peer interaction. You can have the kind of peer programming where students will work together to write, and review code in a given course. This is a way through which you can actually encourage peer-to-peer interaction, or you give them group projects where they can come together and work on a project. As I told you, in this particular course, you are going to come together and work on a project, so in which we are going to foster this peer-to-peer interaction. All right. Having said that, for the deep engagement, how can you encourage deep engagement with the learning content in your lesson or in your class? You can give some examples on hands-on lab where the student will go to the lab and then do the coding for themselves. Okay, through that they will make mistakes, they will commit errors, they will run, it will not run, they will execute the code, will not run, and then they make corrections, they debug it. So they engage with it. When you commit an error, if you have written a program before, if you commit an error, you have to look at it line by line. Where did I make these mistakes? And then from there, you'll be able to correct yourself. Another thing could be case study, where students analyze real-world problems and develop computational solutions. There, they have no choice but to be engaged with the content. Okay, what about an example of where the teacher can use student thinking to foster learning? You can ask the students, some of your students to come out and present from what you have given to them. Let them read the content, make presentation about the content, where you can ask questions, and other students in the classroom can also ask questions in order to challenge the student and also build on their peers' ideas. Then you can also use a formative assessment and feedback. Of course, when you give formative assessment to students, you grade it, you mark it. After you finish grading, you look at what they say and then use that to correct their mistakes. You don't use that grade to penalize them. You only use the grade to encourage them. In essence, that means the grade you give them in formative assessment will not be used as in the computation of their final score in the course. So what you do is you just give feedback, written feedback, identify area of improvement, and encourage the student to improve. Alternatively, when you give a test, a formative test, and you find out that majority of the students don't do well, then you can also shape your lesson. That means you have to reteach the content, or you find a way to re-explain what they didn't get wrong, or you clarify the misconception. So this is when we say the teacher uses student thinking to foster learning. Lastly, how you can maintain equity in your design. You can employ differentiated instruction. You can use universal design for learning, and you can use inclusive group work, where at least you will be able to carry more than 90% of everybody in your class along. So this is very fundamental when you are talking about inquiry-based learning. So 4 foundations are very much needed. The first one being peer-to-peer interaction. The second one being deep engagement with the learning content. The third one being teacher use of student thinking to foster learning. The fourth one being teacher ensuring equity in designing the lesson. All right. Then how can you now implement inquiry-based lesson in inquiry-based learning in your classroom? How can you implement it? What are the steps through which you can implement it? Now you have got to your school, you are posted for TP or wherever, and you want to teach. And you are very passionate about innovative method or advanced method of teaching. You want to use inquiry-based, that is fine, but how can you do it? Number one, you need to design engaging problem. But when we say engaging problem, we mean real-world problems that will connect the student interest and their experiences. You can bring the real-world problem to the class, or you can take the class to the real-world problem. This is possible. Okay, you can assign project to the student where they have to go into the field, they have to go outside of the classroom in order to collect data, analyze the result, and so on. So you design what engaging project. Number two, you facilitate inquiry. As a teacher, you don't just leave your student alone. You encourage them. You stay with them during their design, stay with them during their investigation, and then you collaborate. You encourage collaboration among themselves while solving the problems. So you facilitate this inquiry. You open your office hour where they can come to you and ask you some questions about what you teach. The fourth step is to make sure you employ meaningful assessment. And by meaningful assessment here, we actually mean what you teach is what you should assess. And what you assess is what you should teach. Do not teach what you will not assess. And do not assess what you will not teach. Use formative assessment in combination with summative assessment. Provides feedback for your student and monitor their progress. All right? So when implementing inquiry-based learning, you need to design the engaging projects, you need to facilitate inquiry, and then you need to employ meaningful assessment. Okay? I hope this is fine. All right. So we can proceed to some concrete activities that we can have as examples in the field of computer science. What are some concrete examples through which, if you implement this design this way, you will be able to employ or you will be able to implement inquiry-based learning? Number one is computational thinking assignment. You can design and optimize certain algorithms, create interactive games with conditional statement. You can give this kind of project to your students where you ask them to design some algorithm, a certain algorithm, for instance. They can use Excel or they can use other small or basic programming platform. And they can design interactive games. These things are easy these days. There are some dedicated websites where if you enroll in there, you can design some games yourself. You just need to adapt, make some changes, and then you will be able to see how it goes. If you start from there, you can build on it as time goes on. Another example could be data analysis. You can give them raw data. Okay, give them raw data and let them analyze, let them identify some patterns, let them create some data visualization, let them explain what they can deduce from the data set. So this you can do if you want to ensure inquiry-based learning in your classroom. Then you can talk about cybersecurity. You can ask the student to work on a project where they will investigate internet safety. Like for instance, internet safety of a university. How can they ensure it? Can they analyze cyber threats, and can they develop some kind of prevention strategies to all these cyber attacks? So you can engage your students in this kind of activities, and then you find out that they will be able to be deeply engaged with the content. They will be able to foster peer-to-peer interaction, and you as a teacher, you'll be able to use their thinking to foster your learning, and you'll be able to carry everybody along. Perfect. But inquiry-based learning is so sweet, it's so interesting, but there are some challenges. Just like every other thing, there are challenges here and there, okay? So, but more importantly is for you to identify these challenges and be able to prevent it or to protect against these challenges. Number one is time management. Of course, inquiry-based learning activities require time in planning. It requires time for students to implement it. You need to give students time to think. You need to give them time to interact. Okay, so time management is very important. Time is a factor, but you can manage it. Number 2 is differentiation. How can you make sure that you provide support and guidance to meet everybody's need? This is a big challenge. Oh, you'll be thinking, should I use graphics in this my design, in this my PowerPoint? Should I use picture or only text? Should I put too much text? Some people cannot read well, but as soon as some people are attracted with picture, once they see the picture, that will encourage them to read. So you look at this so that everybody will be carried along. Okay, should I make it video, or I should just make it synchronous where it is online? Everybody will be online and listening to me. Okay, can I record it so that people that are not able to join, or people with bad internet service, or people without Android phone can actually watch the video later on? All these kind of things, you put them together when you are designing your IBL, your inquiry-based learning classroom. Third one is professional development. For teachers, changes are difficult to implement. Everybody understands this. For you to go along with new trend, it requires effort. So you need to equip teachers, just like you are trying to in this particular course, equip teachers with the skills to implement inquiry-based learning in their own personal classroom. Okay? I think if you are able to put all these things together, then you will be able to actualize the power of inquiry-based learning in the classroom. And this power actually lies in the ability of inquiry-based education or inquiry-based learning that empowers students to become active, critical thinkers and problem solvers. So by fostering curiosity, collaboration, and a deep understanding of the subject, this approach prepares students for the dynamic challenges of digital age. So inquiry-based learning is something we advocate for. We have identified what inquiry-based learning is. We have spoken about the foundations of inquiry-based learning. We have spoken about some examples of inquiry-based learning in your classroom. And then we spoke about how you can implement inquiry-based learning. We talk about the challenges and how you can overcome these challenges. I think this is a convenient place to have a little pause now. And there are some few activities we have to do before we proceed. Now, I'm giving you time now to talk. If you have something to say before we proceed, kindly voice out. Let me hear you. You can unmute yourself now and speak if you have something to say.
Good afternoon, sir.
Yes, good afternoon. Go ahead.
Please glance at the implementing inquiry-based learning. Can you please explain it just
once more?
Yes, sir.
Okay.
Just a glance.
Thank you. Let me go back to the text. Okay. So you said we should talk about, say it again, implementation, right?
Yes, sir. Implementing inquiry-based learning.
Yeah. So this basically is talking about now you have your own classroom and then you want to see how you can implement inquiry-based learning. And I said, for you to implement inquiry-based learning, you need to take hold of some 3 things. Number 1, you need to design engaging projects. The project should be engaging. So engaging here means that the problem should be realistic enough that we connect the student interest and then experiences. Don't just bring something from Europe or from America that Nigeria students cannot relate with. Bring something from their own environment, something they can link the knowledge to. Number 2, after you've designed an engaging project, you need to facilitate the inquiry process. Facilitating means that you encourage the students, you encourage them to ask questions, you encourage them to investigate, you encourage them to collaborate, you encourage them to use their potential to the fullest. You don't just design the engaging program and then leave the student alone. You need to encourage them, see them through the process. Number 3 being, you need to make meaningful assessment. Now you have tasked your students, you need to assess the tasks meaningfully. By meaningfully here, we mean you give them feedback when they are doing it, and after they have done it, we give them summative assessment that will test their knowledge. So there must be alignment between the project you give to them and what you assess. You don't teach what you don't assess, and you don't assess what you don't teach. So this is the message. I hope that is clear.
Yes, sir.
Perfect. So now, before we go to the second one, which is on project-based learning, there are some questions here, which we can play around with it. Okay. So you can also unmute yourself and speak.
Good morning.
Okay, I want to believe on your screen you can see something that says poll 1, and it is a question that pop up on your screen. Do you have it, everybody?
Yes, sir. Okay,
so can you answer the question, everybody, on your phone?
No, sir, we haven't.
You cannot?
Yes, sir.
No, you can.
Okay, yeah, we can.
Yeah, you can. Only one person so far. Yeah, we have 2 persons.
Yes.
As soon as we get 25 persons, maybe I will stop you so that we got 25. While other persons can be answering the questions as I speak. So the question here says, which of the following best illustrates the principle of peer-to-peer interaction in inquiry-based learning? The first option says, students independently complete coding assignments and submit them for grading. The second option says, students listen to a lecture on certain algorithms without interacting with each other. C, students work together in peer programming, where one writes code and the other reviews it. D, students follow a step-by-step tutorial provided by the teacher to complete a coding task. A lot of people chose C. 19 out of all of you, 28, who participated, chose C. We have some people who chose other options. So which one is correct?
Sir, C is the answer.
C.
C is the answer. Why C is the answer? Why? Tell me why.
Yes.
Because it's something pet. When something is pet to pair, it's like a cooperation between students to work together and achieve the certain goals.
Excellent. I agree with you. The answer is C, and that's where the majority of you chose. So for those of you who have chosen other options, the answer is C. Get it right now. Students work together in peer programming, okay? And then where one writes code and the other reviews the code. Thank you. The next poll, I can end this one. All right.
Good morning.
Let's have the second one from here. So by now you should be able to see the second poll on your screen.
I've not seen it.
Check, you see it now. How does deep engagement with learning content differ from traditional learning approaches in computer science education?
My own have not shown. My own have not come across.
Yes.
I've not seen it, oh God.
No, it's the network. People have started answering the questions.
Hag.
Okay, I think I've got 20. I can proceed. So how does deep engagement, remember, deep engagement is the second foundation of inquiry-based learning. This question says, how does deep engagement with learning content differ, that is different from traditional learning approaches? You know, in traditional learning approaches, there is no deep engagement. Teacher do all the talking while the student listen. So how does this different from that? Number one, or option A, it focuses on rote memorization of facts and theories. Option B, it encourages students to passively receive information from the teacher. Option C, in which nobody has chosen, it relies heavily on standardized testing to measure student understanding. The last option, where most people chose, it involves students actively experimenting with coding and applying concepts to real-world scenarios. Without mixing words, the right answer is D. You engage deeply when you actively experiment with yourself and when you apply what you know to solve real-world problems. Okay? Thank you. So we can go to the next poll. All right. The next question here. Let me end this one first. And I close. Okay. So the third one. Okay, you have it in front of you. Yep. And this question says, what role does the teacher play in the Socratic seminar method used in inquiry-based learning? The question will soon come up. Yep, you've seen it. What role does the teacher play in the Socratic seminar method used in inquiry-based learning? Maybe we make this to be the last question. Then we proceed with the lesson. Okay, two options are competing. Okay, we have got 20%. All right, so the question here says, what role does the teacher play in the Socratic seminar method used in inquiry-based learning? Remember, in IBL, the teacher role is to facilitate learning. He is not the sole dispenser of knowledge. He is not the most knowledgeable even in the classroom. Rather, his job is to facilitate the discussion. So the first option here says the teacher delivers a lecture. No, not at all. The teacher don't deliver a lecture. The activity is focused on the students. Option B, in which nobody has chosen, the teacher provides direct answers to student questions. No. The teacher assigns a set of problems for students to solve independently. Maybe this is something, but not what we actually want. So what we want is the teacher facilitates discussion by asking probing questions and encourages students to articulate their thoughts. Okay,
Yes.
so the right answer is actually option D. Is it okay, everybody? Thank you.
Yes.
I think we can stop the poll now. So everybody, you can mute yourself back. Let's go back to the lesson. Then after, we are going to take more polls as time goes on. All right. The next subtopic, kindly mute yourself, everybody. So the next subtopic is on project-based learning. Remember, we just finished inquiry-based learning. Now, projects. And you should also remember that we are talking about the advanced methodologies of teaching. We don't talk about this traditional method, direct instruction, lecture method, all this. No, we are talking about advanced one. So which are the teaching methods for this century, for this generation of students. So this method, which we talk about now, is project-based learning in computer science education. So just imagine you are learning how to swim. For those of you who don't know how to swim, maybe reading about swimming techniques and watching videos, maybe it can be helpful. But the best way to learn swimming is to jump into the pool yourself and start it. So you will feel the water if you do that. You understand the movements and adapt your technique through practice. So this hands-on experience is truly what helps you become a good swimmer. Now imagine you are applying the same idea to the concept of computer science. This is where project-based learning comes in. So you work by doing, you learn by doing, you construct your knowledge by experiencing it, by feeling it, okay? So what is project-based learning? Project-based learning is a powerful teaching methodology that engages students in real-world problems. It promotes active learning, it promotes critical thinking, it promotes practical application of what you learn. In the heart of project-based learning is active learning, critical thinking, and creativity and innovation. If you are trying to inculcate or you are trying to build these skills in your student, then you need to look towards using project-based learning in your teaching, at least incorporate it. And like I told you at the beginning of this course, this particular course involves a project where you will go to the classroom, natural classroom, you will evaluate teaching practices of your teachers, you will analyze your data, you will interpret your result, and then you will make a submission. That is a project. Perfect. So what about the key considerations when you are designing a project-based task or a project-based lesson? There are some key considerations you need to take into effect. Number one, just like an IBL, there must be driven question, a question that is central, open-ended, that can spark curiosity and inquiry. Okay? Just like over there, you talk about engaging tasks. Here, you talk about driving question that will catch the interest of your student. Now, when I said it in the first class, that you will go to your teacher classroom, you will evaluate their teaching practice. Something, yes, now I can now evaluate my lecturer in Cox 208 or wherever. So this is how it is. It's engaging. Number two consideration is for you to sustain the inquiry. You sustain the exploration. You sustain the research. And you sustain the analysis of developed solutions. So this is when you are moving or you are thinking as a teacher that uses instructional methodology suitable for this age. Number three is authentic assessment. Again, these foundations, they are in line with IBL because they fall into the same advanced methodology. The driving question, sustained inquiry, and then what's authentic assessment. Over there, we say meaningful assessment. Here we are saying authentic assessment. These are just change of words. So we capitalize on assessment that measure real world skills and your competence. Your skills is what you want to measure. Thank you. Then what about this? When you are now, also key consideration you must take note of is that when you are designing your project-based instruction, you should develop real-world relevance. Make sure the task you are given to your student is relevant in the real world. It is not a kind of hypothetical task, a task that only exists in the virtual mind, not concrete. So where the student can face authentic challenges. Maybe you want to assess your teacher now, and then the time is not permitting you, or the lecturer is not coming that day or something. So where you are going to stumble into how you can analyze the data. Something that has practical application as something that is related to their career. So take note. Again, another component of project-based is for you to foster collaboration and teamwork. And how you can do this for the teamwork, allow your students to collaborate with each other, allow for peer-to-peer feedback, and make sure the environment is inclusive. You promote them. You make sure nobody is left behind. Okay, this guy is the type that is shy, he cannot talk well. You try to pair him with somebody that can talk well so that his potential can come out. So this guy is the one that is lazy somehow. You pair him with people that can encourage him or her. So this is the point. So you make sure you foster collaboration and teamwork as part of the component of project-based learning. Okay, and then lastly, a component of project-based learning is for you to empower student autonomy. Make sure at the end of the day, student can say, yes, I did this. Yes, I discovered this. Yes, I found this solution. Empower them by setting goals, goal setting, by asking them to explore, you don't do it for them, and by asking them to reflect on what they get. If they follow these 3 steps, at the end of the day, we say, yes, I did it myself. So they can take ownership of the lesson, of the content that they learn. So these are the components of project-based learning. So the next thing is, how can you now implement project-based learning in your classroom? As a teacher of computer science in the 21st century, how can you implement project-based learning in your classroom? Number 1, adequate preparation. You need to prepare well for the project. Make sure the projects you are given to your student aligns with the curriculum. You identify the resources they will use, and you plan for time management. There is no time to waste whatsoever. Number 2 is for you to facilitate the project. Introduce the project, guide them through the inquiry, give them all the necessary material, facilitate collaboration, and provide feedback where there is need. And lastly, you should be ready to address their challenges. Let the students know as they are going for the project, they are going to encounter some challenges. How can they assess them? How can they develop what we call thick skin? Thick skin is for you to be able to resist or to be able to persevere if there is challenge, if there is a challenge. So you ensure that the students are able to endure when they face the challenges. You support their diverseness, and you continuously assess and adjust the project so that it can suit the student. All right. Some examples of project-based learning in the classroom: game design. You can create interactive games using programming languages like Scratch, Python, JavaScript. All these are possible. You can develop it on your own. You can also give some kind of web development project to your student where the student can design and develop websites or online portfolios to showcase what they know and the projects. So these are things that are possible. And then you can also expose them to some things on robotics, how they can build robots. This is possible now. In fact, we're having GSS2 or GSS1 students that are learning some of this coding and how to build robots, whether it is a car, this small car that can go by itself or can be controlled with a remote. This is a robot. When you hear a robot, you don't have to think of something big. It can be something small. You start from there. Automated systems, students can also design and build automated systems such as smart greenhouses or home automation. So all the simple one, the office that can off the light by dictating the presence of somebody moving in the office. If everywhere is quiet and nobody is moving, the light will just go off. This is sensor. All these things are possible. They are selling them in the market. You just need to install. Or for instance, this problem of stealing that you have here and there. So you can have some kind of tracker, very small micro tracker you can develop and attach to your object, whether it is your phone or with your bike or with your car or with anything, in such a way that you can be able to trace. Okay? Then data analysis and visualization. This is another way through which you can engage your students, where they can explore data, they can visualize data.
Good morning.
Yes, good morning. Go ahead.
So I have a question. Under empower students autonomy, the goal system, like
under
more
the autonomy,
yes.
You need more explanation.
Goal
Yes.
system. Under the goal system.
This one. So you empower
Yes,
your students to be autonomous. The goal setting. Students should be able to set their goals and take ownership of their learning. You should encourage your students to do this. Ask them, you want to go through this project? Maybe you can go to the class 2 times to assess your teacher, or you can break down the complex tasks into pieces, and then you say, okay, the first week of the lesson, the first week of the project, I'm going to achieve. The second week, I will achieve this, the third week, and so on and so forth. So you can ask them to do that by setting goals. I mean, time-bound goals. The goals that are timely. In 1 week, I want to do this part of the project. Another week, I will do this. The last week, I will do this. So this is what we mean by goal setting. And I want to believe exploration and self-reflection are clear enough for you. Yes? Yeah. Any other comments? Thank you. Any other comments? Okay. If there is no further comment, now we can go to more questions and review questions for you. So let us have some questions based on what we have done. Okay. Okay. In front of you, you will see another question based on project-based learning. It is the responsibility to answer this question as simple as possible.
Following this simplified.
When we get 20 persons, I will stop you. Which of the following best exemplifies the critical role of sustained inquiry in project-based learning? Wow, nice one. Sorry, we cannot see the question. Perhaps your internet. Perhaps the problem is from your internet. Okay, now we can get the answer to the question now. Let's have it. Which of the following best exemplifies the critical role of sustained inquiry in project-based learning? Number 1 can never be the answer. The option A can never be the answer. Student following strict set of instructions. No. But the second one looks appealing. students engaging in a continuous cycle of questioning, researching, and problem solving to develop a machine learning model for predicting weather patterns. This is a process where you have to sustain your inquiry, and the majority of the students actually chose this option. So this is correct. The correct answer is option B. It is not C that says completing a multiple choice task on computer, no. Student listening to a guest lecture, no. So the right answer is option B. All right, thank you. So the next poll, let's have the next one. Okay. You should have that in front of you once more. Take your time to read the question and then punch in your answer. How does project-based learning specifically enhance student creativity and innovation in computer science education? Wow, interesting. So majority of the students actually chose option C. The question is, how does project-based learning specifically enhance student creativity and innovation in computer science education? The answer is by encouraging students to brainstorm ideas, experiment with solutions, and learn from mistakes through open-ended projects. Yeah, thank you very much. So we move on to the next poll.
So my network they show me shege.
Sorry, eh? The next poll is in front of you.
In context of
Are we there? In the context of project-based learning, which strategy is most effective? Amazing.
Wait, I see this person there.
an anti-moko observation clues and encouraging people.
Okay, we have got 20 answers, so we can proceed. In the context of project-based learning, which strategy is most effective in fostering collaboration and teamwork? Assigning individual tasks that do not require interaction, no. Promoting silent work sessions to enhance concentration, no. Establishing clear rules and responsibilities within the project groups and encouraging peer feedback. Limiting the number of group meetings to minimize distractions. The right option, as majority of you have chosen, is option C. Okay, thank you. I think we can stop the poll from here. then we go back to our content, after which we can proceed with the poll once again. Let me stop sharing and then start sharing again. Okay. All right. Okay. So the next topic is problem-based learning. You see, they are very similar. Project-based, problem-based, and then inquiry-based. So what is this all about? This is the last section of our lesson today. Problem-based learning in computer science education. Here, suppose you are a detective, solving a mystery. You are not a DSS, okay? But you are solving a mystery. Okay, each clue you find brings you closer to unraveling the story behind the crime. Okay? Maybe secret agent or something like that, working for the government or the police. You do not have all the answers that you need. You need to investigate. You need to hypothesize. You need to test your ideas. And you need to learn from the process. This approach makes you more engaged and improves your skills as a detective. Now, what if learning computer science could be just as exciting as that? This is when we talk about problem-based learning in computer science education. Now you want to take the role of a detective, a DSS agent, where what? You investigate, you hypothesize, you test your ideas, and you learn through the process. But instead of you investigating crime, here you are investigating content in computer science education. All right? So problem-based learning, it is also founded on three tasks or three important components: authentic problems, active participation, and then inquiry-based. So you can see inquiry-based we talked about initially, it is coming back. So this is telling you that these three advanced methods, they are interwoven. They are like this. They are interwoven. In fact, we can say inquiry-based is an umbrella for them, where all other teaching methodologies that encourages active participation, solving problems, or working on a project, they are all under that umbrella. So problem-based learning, it has to do with authentic problems, where you start with a real-world problem that drive learning and application of knowledge, where your student will be able to actively participate, collaborate, research, and find solutions to the problem, and where your student will be encouraged to be self-directed to learning and reflect on what they have learned. This is what problem-based learning is all about in computer science. Excellent. We have some benefits. If you implement problem-based learning in your classroom, you will be able to foster computational thinking. Remember in our first class, we talk about computational thinking and some sub-skills of this. You will be able to encourage collaboration between your students. They will be able to communicate and leverage on their collective intelligence. And they will be able to become creative and innovative. So because you are going to design a problem that will drive their curiosity, that will drive them to be open-minded, that will make them to be able to listen to contrasting opinion, that will make them to be accommodative of other opinions contrary to theirs. So you argue with your colleagues in order to find a solution to a problem. So you have no choice but to be accommodative in that kind of situation. None of you will become a dictator because you are all colleagues, and you'll be able to express your opinion as you conceptualize it. So these are the benefits. And when you are designing your PBL, your problem-based experience, you need to carefully select the problem. Identify the problem that is authentic, relevant to your student, and challenging enough. A problem is different from an exercise. A problem is different from a question. A problem is different from a task. Rather, a problem is a situation whereby you need expanded knowledge to find solution to it. Okay? Not immediate answer. Okay? The second thing that you must consider when you are designing your PBL is the problem-solving process. You guide your student through exploration, research, and solution implementation. There are different types of models. By the time you come for Sec 303, you will learn some of these models. Okay, the models of problem solving. And by the way, if you did your other level here, you should have been taught something of that in your 108. In Sec 108, there should be something on problem solving in that particular course. Otherwise, you will still be exposed again in 303. And that is how curriculum is done. It is spiral in nature. Okay? Then we talk about the computational thinking. You want to solve a problem in computer science, you should be able to integrate concepts like decomposition, pattern recognition, and algorithmic thinking. Remember, we talk about this when we talk about computational thinking. All right? So take note, this is very important. All right? Good. So how can you now implement PBL in your classroom? Now you have known something on PBL. How can you implement it? The very first consideration we have to do with the learning environment. You need to establish a supportive culture that encourages risk-taking, and then inquiry. It cannot be a military zone. Your classroom should be accommodative enough. So for students to be encouraged to take some risk, they know if they fail, if they didn't get the correct answer, you will not penalize them. It will not affect their grade. Rather, you will encourage them and show them their mistakes so that they don't repeat the same. Teacher's role. As a teacher, you need to facilitate, guide, and provide feedback to your students. This is very important when you want to implement problem-based learning. You need to see yourself as a facilitator. You don't see yourself as a dictator. You don't see yourself as somebody that knows everything and your students don't know anything. No. You see your students as people that you want to facilitate their learning. You want to encourage them. You want to support them to actualize their full potential. This is when you are ready to implement problem-based learning. And so your method of teaching will be quite different because you want to concentrate on what the students are doing, not what you do as teacher. You want to see them, as you can see some students over here, engage with their teachers. Okay, this is what we mean. So authentic assessment. Again, if you want to implement problem-based assessment, your problem-based learning, you need to change your assessment method. It cannot just be multiple choice question. It cannot just be only CA and final exam. Written. No, something more. They should be able to submit a project. They should be able to explore the world on their own. They should be able to come up with their own creativity. Don't worry, 303 is coming. You will develop some of these videos. You will see how it is done. Okay? So you design the kind of what we call authentic assessment, where you incorporate both formative and summative to guide and evaluate the process of your students. Okay? Good. So how can you now overcome the challenges? Of course, when you get into problem-based learning, there will be some challenges along the way. If you want to implement problem-based learning, there will be some challenges. But the most important thing is, how can you overcome these challenges? Number one will be student resistance. In fact, some students will not like to cooperate. They won't like to talk. They won't like to share what they know. You know, some of these students, they still think they are in primary or secondary school. You know, in secondary school, you like to cover your notes, you like to hide what you know, so that you become first position and you get the school prize, you know. But this is a university. Nobody's after that. Your CGPA will not affect my own CGPA. So why don't you share what you know? So when they come into the university, they try to hide what they know. So they will resist any type of activity that will force them to share what they know. So you should be ready for this challenge, and you should be ready to overcome this challenge. You need to emphasize the relevance of this, and then you need to let them to know the significance of solving the problems together. Again, is content coverage. One of the most difficult things for lecturers to do is to have lists of content in your syllabus, and they'll be able to cover the content. They'll be saying, I don't have time. So because they have a lot of things in the curriculum that they are afraid of not being able to cover, they will not have time for this type of activity. They won't give you chance to work collaboratively. They will give you chance to also showcase what you know. They will focus on their content, on their syllabus. But no, it shouldn't be. You need to maintain a balance between the curriculum requirements and then the meaningful problem exploration. You should be ready for this. Again, is group dynamics. In a group of three, only 3 students, even though the 3 students, they are from the same family, you will find that the 3 of them, they are different in one way or the other. There are academic differences among them or individual differences among them. We have one who loves to listen to people. We have the other who loves to watch videos and graphics. We have this one who like to read on her own. So how can you bring them together and allow them to work in the same group? So you need to establish clear expectations and monitor their collaborative efforts. So this is very important, a challenge that you should be able to foster. All right. So some examples of problem-based activities in computer science that you can talk of. You can give some problems to your students where they will develop a mobile app. By the way, develop mobile app is very easy now. There is a kit for it. This mobile app, there is a kit. We have Android kits, you have OS kits, where you just go into those kits and then modify some things, and then you have an app. You don't have to do these things from the scratch. And you can even employ AI that will write some of this code for you. Just copy and put it in the kit, and then you are fine. You can encourage your student to develop educational game, and you can encourage your student to become digital citizenship on the website. So they can develop a website to promote responsible online behavior. All right. So these are some of the activities that you can talk. So when you are embracing PBL in your lesson, you know you will be able to foster critical thinking, collaborative skills, real-world relevance, and then innovative mindset. Now, can we now put these 3 approaches side by side? This is very important. As you can see during the lesson, these 3 things, they are interwoven. You see, when I say inquiry, when I say project, when I say problem, you still find that some things, they are just connected together in the 3 different methodologies. The answer is yes. But the next question is, where exactly do they differ? Where exactly are they different? This is what this table presents. So we have the inquiry, we have the problem-based, then we have the project-based. Let's talk about the focus. The focus in inquiry-based is of student-driven questions and exploration. That's all. You just want the students to have questions that will drive them, and they will explore it, and they will use their own reflection to bring about the answer. But in problem-based, the focus centers around real-world problems as a driving force. However, in project, it is also a real-world problem, but it is an extended problem. Can you see it now? It's not a small problem you can just solve in a class. It's a problem that will require weeks or even months to solve. So it revolves around an extended problem. What about the teacher's role? In inquiry-based, teacher is the facilitator. He guides critical thinking. In the problem-based, teacher is the guide. He provides support and resources. In the project-based, teacher is also a facilitator. He offers feedback and guidance. So this is what we have. Lastly, the nature or the scope of the question. In inquiry-based, the scope is about around a single question or a concept that you want your student to have in-depth exploration. It's a single small problem, but you want them to understand it very well. Then you give it to them in an inquiry that they will brainstorm, they will share ideas, they will communicate, they will collaborate, they will, they will argue with themselves and come out with a solution. That is for inquiry-based lesson. But in that of the problem, in problem-based learning, it revolves around a specific problem, just as in the case of inquiry, encourage the student to integrate knowledge and skills from various disciplines. They bring skills together. They bring their creative skills from arts. They bring their coding skill from computer science. They bring their design from another place. They bring their critical thinking from mathematics or thereabout. And for the project-based, the problem is broad in scope. It is a bigger problem. Allow students to delve into interdisciplinary concepts and develop various skills. They can move beyond their faculty. They can go to other faculty to seek for clarification on what they don't know. So this is what brought the three methodologies together. I hope that is clear enough. All right. So this is a convenient place to stop. And then we shall also take some questions. After that, there will be a small activity where you will be in groups and then make some discussions before we end the class. So let us have questions based on these problem-based learning. Okay. Let's start with this one. Look at the question in front of you. Which of the following assessment approaches aligns most effectively with the principle of, okay, this one is still projects. Let me end this. Let me go to problem.
Yes.
Okay. Yeah, thank you. Can you see that?
I cannot. I need to.
Yep. Which of the following best describes the principle of inquiry-based learning in problem-based learning? Let me reshare it again. Perhaps some of you couldn't see.
So you have seen it now, sir.
You are seeing it now? Okay.
Yes.
Okay.
It was not Ocean.
Yeah, can you see it clearly now?
Yes, sir.
Yes, sir.
Okay, so now put in your answers.
Okay.
So now as we get 18 people now, stop it. Okay, we have got 18 people already. So which of the following best describes the principle of inquiry-based in problem-based learning? Can you see that? Like I told you before, inquiry-based is an umbrella that carries almost everybody along. So majority of you have chosen option B that says students engage in self-directed exploration and research to understand and solve problems. All right. Which of the following best describe the principle of inquiry-based learning in problem-based learning? And the answer is B. Students engage in self-directed exploration and research to understand and solve problems. All right. Thank you. Let's pick the next question. The next question is this. Can you see that?
Benefits of problem-based learning. Problem-based learning. Problem-based learning can have real-world problem.
Okay, interesting. What is the primary benefit of incorporating problem-based learning in computer science education regarding computational thinking? Good. We need 3 more. Yeah. Now we have got 20 or more than 20 people. Now that is enough. So let's see what's going on here. It says, what is the primary benefit of incorporating problem-based learning in computer science education regarding computational thinking? Majority of you chose option C, that says it enhances the ability to break down problems, recognize patterns, and develop algorithms, which is correct. Perfect. So we still have some people that have chosen wrong answers. I hope these people can learn from their mistakes. It minimizes the need for collaboration. This is not true. In fact, anything regarding problem-based learning cannot minimize collaboration. It rather increases what? Collaboration. So take note of that. All right. Let's pick the next question. Okay, somebody asked a question here. Why is the answer not D? I don't know if the person is talking about the one we just finished or the previous one. Let me relaunch this. Somebody is saying why the answer is not D. It focuses only on theoretical knowledge without practical application. No, this cannot be. Yes. Let me look at the question and answer, the Q&A again. Yes, the one we just know. So I think you get it clear now. So when you talk about problem-based learning, it cannot just focus on theoretical knowledge without practical application. In fact, we start with what? Authentic problem. Something that is coming from your experience. So take note of that. All right, let us take another one. Before we leave this, let's launch another one. Look at this one. How does problem-based learning specifically contribute to the development of creativity and innovation in computer science students? Nice one.
Define solution by including experiment. With different approaches exploring and competition. So focusing especially includes the learning mobile and encouraging experimentation with different approaches and experimentation.
Are we okay? We have got 20%, so we can proceed. How does problem-based learning specifically contribute to the development of creativity and innovation in computer science students? Majority of you have chosen option B, by encouraging experimentation with different approaches and exploring alternative solutions. By encouraging experimentation with different approaches, yes, this will foster creativity and innovation, because you come up with your own approach, you come up with your own solution. Thank you.
Yes, sir.
Some of you chose option A, by saying by providing structured lectures and predefined solutions. No, project-based learning, problem-based learning, you don't give structured lecture, predefined solution. You allow your students to explore solutions themselves. Somebody also chose the last option. By minimizing collaborative, no, this cannot even be. Minimizing collaborative work. No, collaboration is part and parcel of what? PBL. You want to encourage collaboration. The essence of even introducing PBL in the first place is to encourage collaboration. Okay, so take note of this. I think we can end this poll now. And then maybe let me read through some of your comments in the chat. Okay, please, yeah, those down to, okay. Your skin is glowing black. Sorry, we cannot help with that. Okay, yeah. All right. So I think now we can stop sharing. So now we now go into another set of activity where you will be able to interact with your colleagues on a single problem. Take note, everybody. I'm going to type a question in the chat. That question, all of you will brainstorm on the answer to the question, and then you come up with a solution, all right, or explanation, not a solution, because there is no fixed solution, all right? So you just need to talk with your colleagues. I will put you in groups and then come up with something you think will explain or will address my question. So the question now, you will find it in the chat, which I'm typing to everybody. In your opinion, what are the peculiar challenges in implementing IBL, inquiry-based learning, in secondary schools in Kaduna State? So this question, I will put you in a group now. You'll find yourself in a group, and then you will discuss, all right, within your colleagues and come up with only 2 challenges. By the time we finish the activity, all of you will now come together and then share your challenges. Come up with 2 challenges, and then you share your challenges. Afterwards, we are going to discuss the solution together. So you're welcome back, everybody. Now this is the time to share what you have got from your discussion. I know some of you have challenges with your network in getting in and out. However, the activity is over. Now it is time for you to share your findings. So group 1, I'm calling on group 1 now. Who is speaking from group 1? Tell us 2 challenges that are peculiar to text of secondary school classrooms in Kaduna State while implementing IBL. So group 1, somebody from group 1, share your answer. Okay, so we have a full house now.
Hello. Good afternoon,
Yes,
sir.
please. Go ahead. Good afternoon.
So actually, I don't know which group I am, but I just want to.
You don't know which group you are? You were? Okay. So go ahead.
So teachers in Kaduna State Secondary School are still using traditional method of teaching, which they have to adapt to this advanced learning techniques. An example of it is that they are still using textbook. They rely much on textbooks. You don't give the students room to brainstorm. You don't give them room to. They don't give out projects for them to brainstorm and then bring out new ideas.
Okay, so what you are saying now is there is resistance to change. Resistance to change is a challenge. That's how to put it. Resistance to change is a challenge that's facing implementation of IBL in Kaduna State Secondary School classrooms. Thank you.
Yes,
Number 2. Number 2, as in the second challenge.
Okay, it's part of my group, so can I take up from there, sir?
Please go ahead.
All right, so I'll say curriculum alignment is
What do you mean by that?
Okay, now curriculum alignment refers to the process of actually ensuring that the content and objectives of the assessments and curriculum of such school is being aligned with whatever activities is going to come up in such group. So if the curriculum of a particular school in Kaduna State does not accept inquiry-based learning or does not fit in inquiry-based learning into their curriculum, it's going to be a challenge for the teacher and the students, everybody to accommodate this learning process.
Excellent. So curriculum alignment could be a challenge. Alignment between what is in curriculum documents and the actual practices in the classroom. If this alignment is missing, then a big challenge can come up for teacher that want to implement inquiry-based. Thank you. So those two challenges that you have mentioned, how can we overcome them? The first one being resistance to change. How can we stop or how can we reduce resistance to change? Any idea from anybody among you?
Yes, sir.
Go
Good afternoon,
ahead.
sir.
Go ahead.
Yes, I feel the way out of this is when we actually understand that we need to leave the old ways of doing things and then coming to the new ways of doing things. This is the 21st century, and then technology has taken over everything. Now, awareness, creating awareness to students, to teachers, schools on the technology that is being put in place to help or foster teaching in schools will help us to know that yes, it is far beyond just the textbooks, it is far beyond just the books. There are other things that we can actually explore that will help our teaching and also make the students understand more. Thank you, sir.
Thank you. You are talking about strong advocacy. Advocacy that will go to each of the schools and let the students know the values, let them know the benefits, let the teacher know the benefits of implementing query-based and make sure they practice it. Thank you. Advocacy. About the issue of curriculum alignment, how can we make sure the teacher align their curriculum with what they teach and at the same time with what they assess the students? Any idea from anybody?
Yes, sir. Can I take it up?
Go ahead, please.
All right. So I would say assessment. They should be able to evaluate the existing curriculum to identify the misalignments and areas needed for improvement. And also collaboration. They can also foster collaboration among the teachers, among administrators, and the curriculum specialists to ensure the alignments across subjects and grade levels.
Okay, thank you. Curriculum evaluation can actually help us in dealing with the curriculum issue. Okay, and at the same time, collaboration, which may come in form of a professional development program, where you give the teacher, you organize professional development program for the teacher. They can design, they can also weigh the curriculum and see what they teach and then evaluate it themselves, apart from the ministry or people from the Ministry of Education doing that. Thank you. All right, let's go to the next group. What are your challenges from the next group? Tell us what to put down. Next group. Who is speaking from the next group? Or speak from your group. You need to unmute yourself if you want to speak. Unmute yourself. Okay, could it be that, okay, you want to say something, Isiaku? Mohammed Kudu. If the network is not allowing you, you can just type it. You can just type what, I think somebody wrote something here. Resource limitations. Somebody wrote here, resource limitations. Yep, maybe there is not enough, insufficient materials. Many schools lack the necessary resources, such as textbooks, laboratory equipment, and digital tools, which are essential for effective IBL. Thank you. And a way to do that, increase funding. Funding source can come from the government, funding source can come from the alumni, and funding source can come from the philanthropists. so who can assist in getting these resources. Another constraint that somebody put is financial constraint, which I don't talk about now, the funding. So financial constraint, budget limitations can restrict the purchase of new materials and the maintenance of existing ones. Thank you very much. These are also challenges that may hinder the implementation of IBL. Just imagine you want to do IBL online like we are doing now. You don't have electronic gadgets in front of you. You don't have data. There is no light. All this kind of issues can affect the process. So that was very good. Yeah. I think that is the only comment I got here from the comment section. Okay, so somebody from group 2, you can talk. If somebody is typing something else, like the access to internet and technology, like you want to incorporate technology within your classroom lesson. And in fact, look at us, even just look at us. We should have the class in this particular lesson in a physical class, but unfortunately, it look like there could be no light, there's not even projector in our class. So how can you make it happen? So you need to move online. And we now even found that online is even more convenient. Some of you, perhaps you have traveled back to your own places for the Salah that is coming. And with this now, we can still be able to follow the class. So without having to come down to Zaria or come down to the campus for this lesson. So access to technologies or access to the internet could be a factor that can hinder it. Infrastructure, adequate infrastructure such as reliable classroom places, suitable classroom places, internet connectivity, electricity may also hinder it. Somebody also mentioned somewhere here the language barrier. In a multicultural and multilingual state like Kaduna, the language could be a problem. Don't be surprised. This language is a serious issue. In fact, you have SS3 students that you have to break your English. You have to break it down before they could get you. If you cannot speak in the mother tongue, then you are in trouble as a teacher in that particular school. So language barrier is nothing to joke with, especially when it concerns a state like Kaduna State. So this is a very good point. So teaching in mother tongue could be an alternative, but what if you are not fluent in the mother tongue? So Emmanuel Matthew, you are saying something, or you are greeting somebody and disturbing us. Okay, I think this is let me get him muted. Yeah. So this is a convenient. Okay, we have somebody saying something. Students may have difficulty with collaboration and teamwork as IBL requires collaboration. I think we also talk about this in the class. Some people they don't like to talk with others. They just like to be their own. They don't like to speak. They don't like to open up. Some they don't even like to share what they know. They just like to keep it to themselves. They like to cover their notes, cover their books, cover everything. So this type of people is difficult when you want to get them in collaboration. And some, they may be shy that if I open my mouth now and speak English, they will say, I don't understand, or I don't know how to speak correct English, and they will be making jest of me. So because of that impression, they will be hesitating to collaborate in a particular IBL activity. So thank you. I think this is a convenient place for all to stop. We meet again after Salah. That will not be next week, okay, because we will still be celebrating Salah next week, but a week after we have our class, which is going to be an activity where you'll be put in groups and then you will discuss part of the content of the notes. So for those of you that are already at home, enjoy your stay. And for those of us that are here to travel, I wish you a safe trip.